The reason you do not hear much about quantum physics is that most people do not need to know about it. It's complicated. Now, what if I told you that the next generation of technology will almost certainly be based on this very physics? You may have heard about quantum computers, those supposedly revolutionary machines that will be able to crack any encryption and run complex simulations quickly. But quantum physics is more than just computers. Its principles applied to other technologies will also create enormous advances. 2025 will be a milestone for quantum physics because the United Nations has declared this year the International Year of Quantum Science and Technology. The significance of this declaration is that countries around the world are beginning to realize that quantum physics is not some esoteric branch of science limited to a handful of academics. Rather, it is an essential tool for staying competitive in the 21st century. To keep up with our allies, countries must invest in quantum. In 2025, you will begin to see the fruits of this investment. So let's talk about what quantum really is and what we can expect from it. First of all, we must discuss the famous quote by Richard Feynman. No one understands quantum mechanics. There is some truth to this. Quantum is extremely complicated and it takes years to master. However, you don't need to understand how it works to benefit from it. For example, you don't need to understand how a television works to enjoy your favorite series. All you need to know is how to turn it on. What you need to know about quantum is that it deals with the behavior of matter and energy at the atomic and subatomic level. When I say behavior, I mean how things move, how they interact, and how they change over time. For example, how does light behave when it hits a wall? Classically, you would say it bounces back. Quantum mechanically, you would say there is a chance that it passes through the wall. How likely is it to pass through? Well, that depends on the energy of the photon and the width of the barrier. The thicker the wall, the less likely it is to happen. This ability of quantum objects to be in two places at once is known as superposition. As the name implies, these objects are in a superposition of states. Superposition is the basis of quantum computing. These qubits can be in a superposition of states, allowing them to perform multiple calculations at once. But wait a second. Is this not nonsense? How can a particle be in two places at once? Or is it really only on the screen? No, this is real, or at least as real as you and me. The best evidence we have that this is true is that we can measure it. Physicists have measured this effect for all sorts of particles, including large molecules and viruses. In fact, everything you see around you is in a superposition of states, including yourself. However, due to decoherence, these superpositions decay very quickly. Decoherence occurs when a quantum object interacts with its environment, causing its wave function to collapse. However, we usually don't notice this because the time scale for decoherence is very short. However, if you carefully prepare and isolate a quantum object, you can maintain the superposition for a long time. This is what happens in quantum computers, which is why they require low temperatures and careful isolation. Now we come to another important concept in quantum mechanics: entanglement. Entanglement is a special correlation between two or more quantum objects. When you entangle two qubits, their fates become intertwined. Measuring one tells you something about the other, even if they are separated by vast distances. Einstein called this spooky action at a distance. But it's not actually that spooky. All it means is that two qubits are correlated. This correlation is stronger than any classical correlation you can achieve with ordinary bits. Entanglement is what makes quantum computing possible. By entangling qubits, you can perform multiple calculations at once. This parallelism allows quantum computers to perform some tasks exponentially faster than classical computers. All right. So what exactly can quantum computers do? Well, there's a lot of hype out there, so let's cut through it. Quantum computers are not going to replace your laptop anytime soon. They're not going to help you write better essays or find better dates. Quantum computers are specialized tools designed to solve specific problems. At the moment, these problems are mostly in cryptography and materials science. In cryptography, quantum computers can break some encryption algorithms, which is why it's important to develop new quantum-resistant encryption algorithms. In materials science, quantum computers can help us develop new materials with desired properties. For example, we'd like to develop new alloys that are both strong and lightweight. Quantum computers could help us find these materials by simulating the behavior of different atoms and molecules. What about drug discovery? Can quantum computers really accelerate the process of developing new drugs? Well, it's possible. But the truth is that no quantum computer has been used to discover a new drug yet. There are several reasons for this. First, quantum computers are still in the early stages of development. They are not yet powerful enough to tackle the complexity of biological systems. Second, we need to develop new algorithms for drug discovery. These algorithms will need to exploit the parallelism of quantum computers. Finally, we need to develop new ways to measure the properties of molecules. All of this will take time, but it's already underway. There are already several companies that are working on using quantum computers for drug discovery. For example, the startup C Quantum is developing a quantum simulator that can model the behavior of molecules. This could allow us to design new drugs that are more effective and have fewer side effects. Another company, Quantum Medicine, is developing a quantum algorithm for drug discovery. This algorithm is designed to exploit the parallelism of quantum computers to speed up the process of finding new drugs. So, what about quantum sensing? You may have heard about these new devices that can detect magnetic fields with incredible sensitivity. These are not just ordinary compasses. They are quantum compasses. Quantum compasses use the superposition of atoms to measure magnetic fields. This allows them to be much more sensitive than ordinary compasses. In fact, they are so sensitive that they can detect changes in magnetic fields as small as a single atom. These devices are called atomic clocks. They use the superposition of atoms to measure time. This allows them to be incredibly accurate. In fact, they are the most accurate clocks in the world. Another type of quantum sensor uses the entanglement of photons. These devices are called quantum light sources. They emit entangled photons. This entanglement allows them to generate random numbers that are truly random. This is important for many applications, including cryptography. But wait, there's more. Quantum sensors can also measure gravity. This is important for many applications, including self-driving cars. Self-driving cars need to know their exact location on Earth. Quantum sensors can measure gravity to very high accuracy, which allows them to determine their exact location. These are just a few examples of the many quantum sensors that are being developed. Quantum sensors are still in the early stages of development, but they have the potential to revolutionize many industries. Finally, what about quantum communication? Can quantum physics be used to create unbreakable encryption? Well, yes, it can. In fact, it already has. Quantum key distribution, or QKD, is a way to distribute encryption keys using quantum entanglement. This allows two parties to share a secret key that is truly secure. That's because any attempts to measure the key will disturb the entanglement, alerting the parties to the intrusion. Now, quantum computers can break many encryption algorithms, but QKD is not one of them. In fact, it is believed to be unconditionally secure. This means that it is impossible to eavesdrop on a quantum communication channel without being detected. Quantum communication is still in the early stages of development, but it has the potential to revolutionize the way we communicate. So when you hear people talking about quantum computing, don't tune them out. This is a revolution that will change our lives in big and small ways. It's happening fast, and it's happening sooner than you might think. It's already started. You just haven't noticed it. But by the year 2025, quantum will be everywhere, and if you know a little about it, you'll be ready. If you want to go deeper into the science behind this, check out our quantum physics playlist.
Thanks for watching.